Welcome to Python programming series. Here I will cover everything from fundamental to advanced topics with clear and detailed explanation. I will upload new videos every week, and if you find my videos helpful, please subscribe to my channel and support me. In this lesson, we're going to discuss about the interpreter and compiler. And also I'm going to answer a question, why Python is called interpreter language. And it is also says that Python is an interpreter as well as a compiler language. Now let's see what is the difference between interpreter and compiler. Before getting understanding of interpreter and compiler, first let's try to understand the programming language. When it comes to the programming language, I have given you the definition here. Programming language is a step-by-step instructions telling the computer what exactly to do. So which means there are some set of instructions we are asking the computer to do and for a specified task. For example, here below I have one simple program which is addition of two numbers where sum c is equal to a plus b, and which is very simple, and we can return very simple program in Python something like this. However, in the backend, it is not pretty straightforward that what we see is naturally c is equal to a plus b. Instead, there are more number of instructions will be there. For example, load the number from the memory location 3001 into a computer. Probably this is a is a variable and some number is being stored here, and it is stored in the memory location 3001. 3001 could be the address in which our variable or some number is stored. Now we are asking to load the number from the memory into the CPU. And also the second instruction is load the number from the memory location 3002 into the CPU. And third instruction is we are asking to do the arithmetic operation by adding the two numbers in CPU. And finally the result I'm asking to store in 3003 location. So this is the instruction. This is a set of instructions what the computer will generally receive. If you look at the simple program, c is equal to a plus b. It looks complicated, right? Yes, it is complicated, but however, in general, it is way more complicated than what we are actually seeing. Instructions are even more complicated, because the instructions the computer will receive, it's not in text, or it will receive the instructions in ones and zeros. That is what the language that our computer will understand. Computer does not understand the English language. It only understands the language ones and zeros. For example, if you encode these instructions, it will look something like this, and completely in zeros and ones. And this kind of language is called machine language. And whereas a language, what we see naturally like c is equal to a plus b, which is very simple, and that is called high level language. And this whole machine learning language is happening in the backend. Now with this statement which I have passed, you might get a question. How to convert the high level language to machine language? There are two ways we can do this. The one is you can use a compiler, and second one is we can use an interpreter. Let's try to understand what is a compiler. A compiler is a computer program itself, and that will translate to machine language. And here is a diagram which I have given to you, where we have a source code, which is a high level language. And from the high level language using compiler, we are converting into the machine code. And this machine code could be the binary or executable files. And where basically it contains all the ones and zeros which can be understood by the computer. And this is going to be run in the backend. In order to get the output, we are going to run this machine code and gets the output. That's how the compiler will work. The one of the example of the compiler language is C or C++. Let us consider a C++. Probably you have written a program in C++, some kind of a text document or some kind of a editor. And from there, we cannot run the C++ program directly. What you need to do, you need to compile the program first. And once you compile the program, you will get a binary file. And now you're going to run that binary file in order to get the output. Such kind of languages where we are going to use the compiler to convert into the machine code, and such languages are called compiler language. Now let's understand what is an interpreter. Unlike compiler, interpreter will understand the computer program. It will understand, analyze, and execute the source code step by step, which is line by line. Interpreter will not do any kind of translation. Rather, it will understand the code and executes line by line. With this, let me summarize the understanding that what we have for compiler and interpreter. The first one is the compiler. In the definition states that compiler will translate the high-level language to the machine code. Whereas interpreter, it doesn't do any kind of translation to the machine code. Instead, it will understand the program and execute the code line by line at the runtime. In the compile language, generally we'll compile the program only once and get the executable file. And now we can run the executable time n number of times. Whereas when it comes to the interpreter language, we have to use the interpreter for every execution. Every time you run the code, you have to use the interpreter to run the code. And some of the examples of the compiled languages are C, C++, Java, Rust, Go, Swift, Fortran, Object-C, and many more. These are the popular languages which will use a compiler. When it comes to the interpreter languages, here are the examples. We have Python, JavaScript, Ruby, PHP, Perl, Lava, shell scripts, etc. And these are all the languages which are interpreter language. Now let's come back to the statement. Python is an interpreter as well as a compiler. If you remember, at the starting of this lesson, I have made the statement that Python is an interpreter as well as a compiler language. Yes, exactly. Typically, Python is an interpreter language only, which it will read the source code line by line. Now, where exactly this compilation comes here? When we look into the standard Python execution, where when you are trying to run the .py files, basically those are the Python files, the interpreter will first compile the .py files into bytecodes. First of all, bytecode is not a machine code. You can treat that it could be interpreted between the high-level language and the machine code. Could be a low-level language. And these bytecodes, if you generally aware of the Python, when you're trying to execute this, you might see some files like .pyc files, and which is actually stored in __ pycache folder. And here the .pyc files are called compiled files. Before executing, what Python interpreter will do, it will first compile the files and store that in .pyc files, and then Python will execute the bytecode. Generally, the Python interpreter is also called the CPython. You might see when you're trying to installing the Python, you might see this CPython. So CPython is nothing but the Python interpreter, and that will execute the bytecode at the runtime. And this makes the runtime much more faster. That's the reason Python is called interpreter as well as a compiler, where compiling is done by the Python interpreter itself. Now let's look into the few more comparisons of compiler and interpreter. We already see the first 3 examples. Let's look into the example from 4. When it comes to the performance point of view, compiled languages are generally the more faster than the interpreter language. The reason is, since in compiled language, it already converted into the machine code. Now all it needs is to execute the binaries. Whereas interpreter is slow because interpreter need to execute line by line. And portability point of view, compiled languages are generally platform dependent. Whereas interpreter languages are platform independent. But of course it depends upon the interpreter. What I mean, the platform dependent and platform independent. Platform dependent means, for example, you have a C++ program with you and you have compiled that and you get some binary file. And that binary file probably you have compiled in the Windows, and you might get some binary file and that can be executable in Windows. But that binary file cannot be executed in other operating system like Linux or Mac, right? Whereas the interpreter language, since it's all depends upon the interpreter, all you have to do is that you have to have the interpreter and it will execute the code line by line. That's one of the advantage of the interpreter language over compiled language. Whereas when it comes to the error checking, compiler will only do the error checking at the time of compilation, but not at the execution. Whereas interpreter will do the error checking at the time of execution. When it comes to the use cases, compiled languages generally used for the critical and high performance applications. Like for example, if you want to create an operating system and you want to create some kind of a mobile applications which need the high performance, and some desktop applications which we need the high performance, example Photoshop or any kind of video editing software which need the high performance, for such we generally use a compiled language. Whereas for interpreter language, where we don't require such high performance, like some web developing, scripting, data science, automation, etc., we can use the interpreter language. And when it comes to the memory usage, compiled language are more memory efficient, whereas interpreter language is less memory efficient. And again, some of the example use cases where we will use a compiled language in operating system, and when in the embedding system, for example, you want to embed the program into some VLSI devices, compiled languages were very useful. Whereas interpreter languages, and obviously the data science, web development, as I told you, wherever we require some not much heavy performance, we can use the interpreter language. And of course, it's most popular and easy to develop. All right, this is what the difference between compiled language and interpreter language. And also I try to explain you why the Python is called interpreter as well as a compiled language. If you like this video, please do subscribe to our channel and hit the like button. And I'll see you on the more interesting videos like this. Until then, happy learning.